S. The process of increasing the number of oxygens called oxidation and decreasing the number of hydrogens called oxidation, and another two definitions for the oxidation that are loss of electrons. Loss of electrons. The process of loss of electrons is called oxidation, right? So what about loss of electrons? So any metal that will be involved, any metal that will be involved for losing of electrons, that is called loss of electrons. Just see here. So zinc is converted to the Zn plus 2 plus 2 electrons. So Zn plus 2 plus 2 electrons. This is loss of electrons is called oxidation process. Or else the increasing the oxidation state also called oxidation. Zn is gives rise to Zn plus 2. So means initially zinc oxidation state is 0. Further that is converted to plus 2. So then coming to the reduction, decreasing the number of oxygens. Decreasing the number of oxygens, exactly opposite to the oxidation. So that is called reduction. Addition of hydrogens called reduction. And gaining of electrons, the process of gaining of electrons is called reduction. The example of Cu plus 2 electrons gives rise to Cu plus 2 electrons gives rise to copper, right? So then the gain of electrons, the process of gain of electrons is called reduction. And here at anode, the always oxidation takes place. Whenever we are discussing about the electrode, that is anode in this electrochemistry, that will be always acts as anode. At anode, always oxidation will take place. So any cathode electrode will be there. At cathode, always reduction will be takes place, right? So for example, two electrodes we are able to use to connect with each other. One is obviously acts as anode, the other is acts as cathode. Which one is acting as anode and which is acting as cathode? That is depends on their reduction potentials. If the reduction potential is more of one metal ion, that is always acts as cathode, that will be involved in reduction. So if the reduction potential of electrode will be less, that is involved in oxidation process, right? So coming to the example, right? So one example for the redox cell or redox reaction, that is the Daniell cell, right? So Daniell cell. What is the construction of the Daniell cell? Yes, all of you mute yourself. All of you mute yourself. Right. So simply here how to construct this one, Daniell cell. So we'll see, right? So this is the construction cell of the Daniell cell. Or else how we are going to construct means, first take one beaker in a zinc sulfate solution and the zinc rod was dipped in that zinc sulfate solution. And in another beaker, take copper sulfate solution and copper rod is dipped in that copper sulfate solution. These two, zinc rod and copper rod, are connected to the external battery. And also these two connected with a salt bridge. So this is the U-shape glass tube which consisting the potassium chloride or ammonium nitrate solution with agar-agar salt, that can be acts as this salt bridge. So once this connection will be set up, right? So the zinc having reduction potential is less. So that's why it will be involved in oxidation process. So therefore the zinc metal rod is acts as anode. At anode, oxidation will take place. So oxidation process means, as we discussed earlier, so that is
Loss of
loss of
electrons.
electrons. The process of loss of electrons is called oxidation. Therefore, zinc is gives rise to Zn plus 2 plus 2 electrons. Zinc is gives rise to Zn plus 2 plus 2 electrons. So then this zinc lose the 2 electrons that will be traveled through the zinc rod to copper rod. So then the copper is gaining the 2 electrons, that copper plus 2 gaining 2 electrons will be converted to the copper. That is the process of reduction. So means the both oxidation and reduction process takes place in this experimental setup. So therefore we'll get the overall cell reaction. So this is the overall cell reaction. Zinc is gives rise to Zn plus 2 electrons, and the copper plus 2 electrons gives rise to copper. Here copper plus 2. So just wait. Right. So here this is the copper plus 2. This copper plus 2 will be gaining 2 electrons that will be converted to the copper. So therefore the overall cell reaction Zn plus copper plus 2 is gives rise to Zn plus 2 plus copper. Right. So the zinc will be undergo oxidation. Zinc is converted to the Zn plus 2. That is the process of oxidation. This copper plus 2 is converted to the copper. This is the process of reduction. Both oxidation and reductions are takes place in that single reaction. Such reaction is known as redox reaction. Redox reaction. We are going to find out. We are going to find out the potential for this redox reaction by the application of Nernst equation, right? So that potential will be expressed as electromotive force, EMF, right? So the EMF of the Na cell that can be determined with the following equation. So means with the help of this redox reaction, right? So this double vertical line, right? So double vertical line will indicates a salt bridge, right? So the double vertical line is always indicates a salt bridge, and the right side of the salt bridge is always cation. Oh, sorry. So this double vertical line indicates a salt bridge. The right side of the salt bridge is always cathode. Always cathode. So at cathode, which reaction takes place? That is, at cathode, reduction will be takes place. So this is what left side is anode. At anode, which reaction takes place? At anode, which reaction takes place? Oxidation takes place.
Oxidation.
So right side is the cathode and left side is the anode. In this Daniel cell case, right side is cathode, means that is copper rod is acts as cathode. Therefore, copper plus 2 by copper. This is a representation of the reduction process. And the left side is the anode. The anode is represented with Zn by Zn plus 2. Therefore, the EMF of this cell, this is the overall cell representation. Therefore, the EMF of the cell can be calculated with the help of these following formulas. So one is EMF is equals to electro reduction potential of right hand cell minus reduction potential of left hand cell. Reduction potential of right hand cell, the right hand cell is what? Cathode. So minus the standard reduction potential of cathode minus standard reduction potential of anode. Or else, if both the electrodes are having only oxidation potentials or reduction potentials, we have to use minus is the charge. Means both the electrodes are having either oxidation potentials or reduction potentials, we can use minus. Or else one is having oxidation potential, one is having reduction potential. So therefore, we have to utilize the plus charge. So that means the standard reduction potential of cathode and a standard oxidation potential of anode. So whenever one is having oxidation potential, one is having reduction potential, at that time we have to use the positive charge to get the overall EMF of the cell. To get the overall EMF of the cell. So this is the cell representation. With the help of this, we are getting EMF of the cell. So here, for example, for the Daniell cell, right? So we are going to calculate the EMF that will. So this is the Daniell cell, Zn plus 2, double vertical line, copper plus 2 by copper, right? So right side is cathode and left side is anode. So then the oxidation potential of zinc, that is 0.76 volts. The oxidation potential of zinc is 0.76 volts. Then reduction potential of copper is 0.36 volts, right? So therefore, EMF is equals to, one is having oxidation potential, this is having reduction potential. Therefore, we can use the sum of oxidation and reduction potential that will give total EMF of the cell, that is 0.34 plus 0.76, that is the 1.1 is the electron volts. 1.1 is the EMF of the cell, right? So or else one is having oxidation, one is having reduction, right? So but here we have to take both oxidation potentials, right? So in the next case, both are having oxidation potentials. So in that case, we'll see what was the EMF, right? So this is the Zn plus by Zn plus 2 means oxidation. The oxidation potential of zinc is 0.76, right? Plus 0.76 oxidation potential. Then oxidation potential of copper is minus 0.34. So therefore, both oxidation potentials will be there. Right side minus left side. That means minus 0.34 minus of 0.76. Therefore, minus 1.1 electron volts. So what this represent, any reduction potential will be there. So the standard reduction potential of any electrode, E of standard reduction potential, SRP. Standard reduction potential of any electrode, which is equals to negative charge of, which is equals to, right, negative charge of standard oxidation potentials, right? Any reduction potential we have. So if that we want to convert into the oxidation potential, so just put minus. Or else if we have standard oxidation potential, so that we need to convert into the reduction potential, just take the symbol of minus. So this is the representation of oxidations and reduction potentials of the electrodes. Oxidation and reduction potentials of the electrodes. With the help of concept of this, the Ernst derived one equation to calculate the EMF of this single electrode potential. Single electrode potential. So what is the Ernst equation? How it is derived? With the help of Ernst equation, how getting we are going to getting EMF of the single electrode potential, right? Right. Are you able to see the screen?
Yes, sir.
Yes.
Yes, sir. Hmm. Screen not changed.
Yeah. So this is the Nernst equation, right? So the derivation of Nernst equation we'll see. Screen was not appearing.
No, sir.
Yes, what about the screen?
The previous screen only.
Is it visible?
No, sir.
No,
No.
sir. No.
No, sir.
Just
Okay. Okay, just wait. I will join in another device, right? Yeah, right now.
mm,
Yes, sir.
Is it
just
visible?
coming. Yes.
Yes, sir. It's
Yeah,
visible.
yeah. Yes, just coming.
Yes, sir. Okay, fine. So any problem will be there, you have to mention in the chat box, right?
Okay, sir.
Whether screen related problems or voice problems, anything will be there. Okay. Right. See, Nernst equation, right? So Nernst equation means the reduction potential of single electrode that can be determined using Nernst equation, right? So as we discussed that reduction potential of zinc is 0.76 and the reduction potential of copper is 0.34, right? So those reduction potentials can be determined with the help of Nernst equation. So what the Nernst derived equation, with the help of that, how we are going to getting the reduction potential of the electrodes, we'll see. So any reduction potential, right? So any reduction potential of single electrode potential that can be depends on these three parameters. One is nature of the various constituents implied, means what are the constituents we are going to utilize to get the EMF of the cell. Then the temperature also will affect. Then activity of the reactants and products. So these are the three parameters are responsible for the determination of the electrode potential of the single electrode using Nernst equation, right? So for which we have to consider one general reaction. We have to consider one general reaction. With the help of that, we'll get the Nernst equation. Okay. Right. So that general equation was A plus B is equals to C plus D. The small a, small b, and small c, small d are the number of moles of reactants and products. The small a, small b, small c, and small d are the number of moles of reactants and products. In this particular reaction, one of the thermodynamic property, that is the Gibbs free energy, that can be written as, means the change of Gibbs free energy. Delta G is equals to delta G naught plus RT ln activity of the products. What are the products here? C and D. Then activity of the reactants, that is A and B. The small a, b, c, d are the coefficients, right? So which are comes power. So during consideration of the activity. So means delta G is equals to delta G naught plus RT ln activity of products by activity of reactants. Now we know the relationship between, so what was that relationship means, right? So the change of free energy and EMF of the cell, right? So means the Gibbs free energy and the EMF of the cell has a relation. That's why we considered that Gibbs free energy parameter change for the particular reaction. So that is delta G is equals to minus NF E cell and delta G naught is equals to minus NF E naught cell. Delta G is equals to minus NF E cell and delta G naught is equals to minus NF E naught cell. These two delta G and delta G naught values are substituted in above equation in place of delta G and delta G naught. So therefore, we'll get the next further equations, right? So simple, take a general equation and consider the thermodynamic free energy change and then got the relationship between delta G and E cell, right? So the delta G and E cell, delta G is equals to minus NF E cell, delta G naught is the standard free energy, that is the minus NF E naught cell, right? Therefore, substitute above values in that above equation, that is minus NF E cell is equals to minus NF E naught cell plus RT-ln activity of the products divided by activity of the reactants, right? So now this will be multiplied with minus and divided with NF on both sides. So here divided with minus NF get cancel. Here NF get cancel. So that appears in the next equation, right? Divided with NF and minus NF get cancel. Here NF and NF get cancel. Here RT by NF, right? Here is missing because dividing with NF on both all the sides. RT by NF ln activity of the products by activity of the reactants. Therefore, E cell is equals to E naught cell minus RT by NF ln activity of products by activity of reactants. If we remove ln with the logarithm, that is E cell is equals to E naught cell minus 2.303 RT by NF log of activity of products by activity of the reactants. This is the Nernst equation. With the help of this the reduction potential of single electrodes can be determined. So further, the entire concept of electrochemistry that depends on the application of the Nernst equation. So what is the Nernst equation? How we are going to apply the Nernst equation to the reactions, right? So that we will see. So is it clear about Nernst equation? Yes. Reduction potential of single electrode that will be depends on three parameters, that is nature of the constituents employed. Once again we'll see, right? So the reduction potential of single electrode that can be determined using Nernst equation, right? So that reduction potential will be depends on nature of the various constituents employed, then temperature and activity of the reactants and products. These are the three parameters. Then further, consider a general equation, that is A plus B is gives rise to C plus D. A plus B is gives rise to C plus D. Then one of the thermodynamic parameter that is the Gibbs free energy. The change of Gibbs free energy, that is delta G is equals to delta G naught plus RT-ln activity of the products by activity of reactants. Therefore, the relation between the change of free energy and the EMF of the cell is known. That is delta G is equals to minus NF E cell and delta G naught is equals to minus NF E naught cell. These two values are substituted instead of delta G naught and instead of delta G. So we'll get this next equation, that is the minus NF E cell is equals to minus NF E naught plus RT ln activity of the products divided by activity of the reactants. So then this is simplifying, means we are going to remove this minus NF because we want only E cell EMF of the cell. That's why divided with minus NF on both sides. Then finally we'll get the Nernst equation, right? So see again Nernst equations, right? Two Nernst equations will be there, one with ln and other one with ln. Right. So these are E cell is equals to E naught cell minus RT by NF ln activity of the products by activity of the reactants. So in place of ln, if we take logarithm, right? That is E cell is equals to E naught cell minus 2.303 RT by NF log activity of the products by activity of the reactants. E cell means EMF of the cell or potential of the cell. E naught cell means standard potential of the cell. R is the gas constant, T is the temperature, and N is the number of electrons. Then F is the number of Faradays. 1 Faraday is equals to 96,500 coulombs. These all are parameters which are included in the Nernst equation. Nernst equation. So further Nernst applications will be there, right? So how we are going to apply that Nernst equation to the various cells, right? So, and various topics will be discussed with the help of Nernst equation, right? So are you understand the derivation of Nernst equation? Yes. Yes. Are you understand? Yeah. Okay. Right. Now further one more topic will be there, that is the electrochemical cells, right? Electrochemical cells. So electrochemical cells are classified into two types. One is the chemical cells and other is the concentration cells. One is the chemical cells and the other is the concentration cells. What are the chemical cells? What are the concentration cells? Then even the either chemical cells or concentration cells that are further divided into two types. One is without transference and with transference. Without transference and with transference means the chemical cells without transference and chemical cells with transference. Concentration cells are again two types, electrodic concentration cell and electrolytic concentration cells. So these electrolytic concentration cells are again two types, that is without transference, then with transference and without transference. Then electrodic concentration cells are two types, that is the gas electrode and the glass electrode, right? So what are the chemical cells? What are the chemical cells? Right? So chemical cells means the EMF is developed due to the chemical reactions only, right? So see, this is the chemical cells. The EMF means the potential is developed. How the potential is developed means due to the chemical reactions. So due to the chemical reactions, the potential was developed. Such cells are known as chemical cells. Chemical cells. The EMF is developed due to the chemical reactions present in the cell are known as chemical cells. Then concentration cells means the EMF is developed due to the transfer of a substance or ionic species from high concentrated electrolyte solution to the low concentrated electrolyte solution are known as concentration cells. Right? Simply, the potential is developed due to the chemical reactions that are considered as chemical cells. The potential is developed due to the transfer of any substance or ionic species from high concentrated electrolyte solution to the low concentrated electrolyte solution. Due to transfer of these ionic species from one solution, concentrated solution to other concentrated solution, the EMF is developed. So that cell is known as concentration cells, right? So clearly you have to focus and understand the concept. Understand the concept, and we'll discuss about without transference and with transference. Without transference means simple. They do not involve a direct transfer of ionic species from higher activity to the lower activity of electrolyte solution across the junction. Right? So what here going to say, so this is the one junction will be there. So this is having high concentration, that is the A2. This is having low concentration, that is the A1. So what is happening here means, if there is a direct transfer of ionic species, any ions like positive ions or negative ions which are transferred, the positive ions or negative ions which are transferred from A2 to A1, that is with transference. A direct transfer of ions will be there, that is called with transference. There is no direct transfer, even though the potential is developed. So that is the without transference. That's why we call as they do not involve in transfer of ionic species from higher activity to lower activity across the junction. So then coming to the with transference, right? With transference means they directly involve the transfer of ionic species from higher activity to lower activity across the junction, right? So across the junction, a direct transfer will be there. So that is called with transference. If there is no direct transfer, that is the without transference, right? So these are the concept of chemical cells and concentration cells with transference and without transference, with transference and without transference, right? Now we are going to construct the EMF of all those things like chemical cells with transference and without transference, and concentration cells with transference and without transference. All those equations are going to determine. So that is in our syllabus, and which is also important for exam point of view, right? So once again, I am reminding that is chemical cells and concentration cells. Chemical cells means the potential is developed due to the chemical reactions. Concentration cells means the potential is developed due to the transfer of any substance or ionic species from high concentrated solution to the low concentrated solution. Without transference means there is no direct transfer of ionic species from one electrolyte solution to other. If there is a direct transfer of ions, either positive or negative ions from one electrolyte to another electrolyte, so that is with transference. These without and with transference are applied to chemical cells and concentration cells. We will get all those four equations that are chemical cells with transference, chemical cells without transference, concentration cells with transference, and concentration cells without transference, right? How we are going to construct all those equations, we'll discuss. Okay. Right. Are you understand that electrochemical series? Then concept of chemical cells, concentration cells with transference and without transference. Is it clear? Okay. Right. So now determination of chemical cells without transference. The heading itself will represent chemical cells. Chemical cells means the potential is developed due to the chemical reactions. Without transference means there is no direct transfer of any ionic species, right? With the help of these two parameters, we are going to construct the chemical cells without transference EMF equation, right? Right. So what we are going to take care means to construct the chemical cells without transference. Chemical cells without transference, two electrodes and one electrolyte must be selected. What we have to select means two electrodes, right? Two electrodes and one electrolyte. One electrolyte. Two electrodes and one electrolyte must be selected. What are the two electrolytes? Two electrodes and what is the two electrolytes means? One of the electrolyte, that is the HCl. The HCl is an acts as electrolyte in which H plus ions and Cl minus ions will be there. H plus and Cl minus ions. So one of the electrode that is reversible to the H plus ions. The other electrode is reversible to the Cl minus ions. The two electrodes are like hydrogen electrode and chlorine electrode. Right? Simple HCl is an electrolyte should be considered, right? To construct the EMF of chemical cells without transference, two electrodes and one electrolyte must be selected, right? In which one of the electrode is reversible to the cation and another electrode is reversible to the anion, right? So consider HCl an example of an electrolyte solution in which one of the electrode is reversible to the H plus ions, that is the hydrogen electrode. The other will be reversible to the Cl minus ions, that is the chloride electrode. That is silver chloride by silver, right? Or mercury chloride by mercury. These are the electrodes, that is silver chloride by silver or mercury chloride by mercury or chloride electrode. These are examples for the reversible for the Cl minus ions. Means these we have to select HCl is an electrolyte solution and one of the electrode is the hydrogen electrode and the other electrode is the chlorine electrode, right? So therefore the EMF is developed due to the chemical reactions taking place when electrodes immersed or dipped in the electrolyte solution. Okay, right. So see the EMF is developed. So as we told that the chemical reactions will be takes place, the potential is developed, that is called chemical reactions, right? So two electrodes which are dipped in electrolyte solution. Here electrolyte solution is the HCl solution. HCl is an electrolyte solution, right? So one of the electrode is reversible to the H plus ions, that is the hydrogen electrode. The other electrode will be the chlorine electrode, right? So this hydrogen electrode gives the potential, that is the E1. Chloride electrode gives the potential, that is the E2. The sum of these two that will give total EMF of this cell. That is, therefore, E cell is equals to E1 plus E2. The sum of these two will give EMF of the cell, right? So one of the electrode is reversible to the cations, the other electrode is reversible to the anions, right? So the electrode which is reversible to the cation, that is H plus ions, is called hydrogen electrode. The electrode which is reversible to the anions is called chloride electrode, that is silver chloride electrodes, right? So here two electrodes will be there. One is the hydrogen electrode and the other is the silver chloride electrode. If the hydrogen electrode is acts as anode, so means here one of the electrode is acts as anode. At anode, which reaction takes place? Always oxidation takes place. How to write the oxidation of hydrogen electrode? That is, half of H2 gas atmosphere is gives rise to H plus electrons. Only hydrogen consisting one single electron. If that hydrogen lost to that electron, that can be represented as half of H2 gas atmosphere gives rise to H plus electrons. This is the equation. Now applying the Nernst equation to this equation. This is the main task to get the solution of chemical cells without transference, right? Any reaction will be there. As we discussed previously, A plus B is gives rise to C plus D. We are getting the Nernst equation, that is the E cell is equals to E naught cell minus RT by NF ln activity of products by activity of reactants. So that is the application of the Nernst equation. So that was application of Nernst equation. Nernst equation application means, keep it in mind, E cell is equals to E naught cell minus RT by NF ln activity of products by activity of reactants. Activity of products by activity of reactants. So therefore that will applied here. E of H2 is equals to E naught of H2, means this is the E cell, this is the E naught cell minus RT by NF ln activity of the products divided by activity of the reactants. What are the product here? That is the H plus is the product. What is the reactant? That is the half H2 gas is the reactant, right? For reactant is the gas, that's why we are going to consider the pressure. The product is the ion, that is the liquid, that's why we have to consider the activity. That is A of H plus. The pressure is 1, and is there any is there any solid or gases? The activity becomes 1. Only liquids has activity, that we should consider, right? So therefore denominator will be left over. So then E of H2 is equals to minus RT by NF ln activity of H plus. Because the standard reduction potential of hydrogen electrode is 0. E naught of H2 represents the standard reduction potential of hydrogen electrode. The standard reduction potential of hydrogen electrode becomes 0. becomes 0. So therefore, we'll get E1 equation. This E of hydrogen electrode means that is E1. E1 we are getting. Now the same concept is applied to the chloride electrode. So once hydrogen electrode is acts as anode, the chloride is always acts as cathode, because this is the redox reaction. So once hydrogen electrode is acts as anode, the other is obviously acts as cathode. So therefore, chloride electrode is acts as cathode. Therefore, chloride electrode is acts as cathode. At cathode, the reduction will take place. At cathode, the reduction will takes place. That is, silver chloride plus electron gives rise to Ag plus Cl minus. This is the reaction. Means the hydrogen is giving one electron. That electron is gained by the silver chloride. So that will be converted to the Ag plus Cl minus. How the chemical reactions will take place means, one of the electrode is losing electrons, the another electrode is gaining that particular electrons. Here hydrogen electrode is losing one electron, the silver electrode is gaining that particular electron. So therefore, silver chloride is gaining that electron and converted to the Ag plus Cl minus, right? Ag plus Cl minus, right? So here not Ag plus, only Ag, because only one electron is there, right? So make it some corrections. I will rectify while sending the notes, right? So that is Ag plus Cl minus, because only one electron is there. This one electron will be gained by the chlorine. So therefore that will be converted to the Cl minus. Ag won't be converted to the Ag plus, right? Right? Ag plus Cl minus. Now apply the Nernst equation, that is E2 is equals to R. E of AgCl is converting Ag. The representation was AgCl by Ag minus RT by F. Ln activity of the product means activity of Cl minus into 1 divided by 1, because Ag is the solid and AgCl also solid. Ag is the solid and AgCl also solid. For solids, activity is 1. So therefore, we'll get this equation. Therefore, E2 is equals to E naught of AgCl by Ag minus RT by F ln activity of ACl minus. Therefore, the overall equation can be written as, the overall equation means one is oxidation will be there, other one is the reduction. By combining of the two equations, we'll get overall cell reaction. This is the overall cell reaction. That is half of H2 gas atmosphere plus AgCl gives rise to Ag plus HCl of A1. Now for this equation, applying Nernst equation, by applying the next equation to this overall equation, we'll get the EMF of chemical cells with transference. Chemical cells, sorry, without transference, right? Or else by combining of this E1 and E2. Two procedures will be there, E1, E2 are there. By adding this E1 and E2, by adding this E1 and E2 also will get the solution, or the Nernst equation is applied to this overall reaction, will get Nernst, will get EMF equation for chemical cells without transference. This is the overall equation, right? So then apply the Nernst equation for this overall equation. What was that overall equation means? The hydrogen, this is the hydrogen electrode is converted to the H plus, that is the oxidation. AgCl is converted to the Ag and Cl minus, that is the reduction. Both oxidation and reductions are takes place in a single reaction, that is called redox reaction. So for this redox reaction, we are going to apply the Nernst equation. That is E cell is equals to E naught of cell minus RT by F ln activity of the products. Here products are HCl will be there. Ag is the solid. No need to consider activities for the solids because unity. AgCl is the solid. Therefore, this is also unity. This H2 is the gas. Therefore, this is also unity. Means only one parameter that is in the product, that is activity of the HCl. Therefore, E cell is equals to E naught of AgCl by Ag minus RT by F ln activity of HCl. Therefore, the activity of electrolyte solution can be determined with the help of above equation, that is chemical cells without transference. This is the equation represents chemical cells without transference. There is no direct transfer of any ionic species, even though the potential is developed. That potential, developed potential can be derived from the concept of Nernst equation. This is the equation represents chemical cells without transference. This is the EMF equation of chemical cells without transference. If there is a with transference, means direct transfer of ionic species from one electrolyte solution to the other electrolyte solution. So that is chemical cells with transference. Chemical cells with transference. So this is the concept of chemical cells with transference and concentration cells without transference and concentration cells with transference and liquid junction potential and further some more topics. So that we are going to discuss in the next class. Okay. Are you people understand the concept? Yes.
Yes, sir.
Yes, I can share the notes to you. You have to write the notes, right? Today notes and tomorrow notes, I will send by tomorrow. You have to write the notes. During writing the notes, if you have any doubts, you can ask in the next class. Okay. So without writing notes, you are not able to understand the concept. Definitely you should write once in your notebook. So while writing, so just go through the concept. Even you are getting trouble to understand those concepts, right? We will discuss in the further classes. Okay. So the overview of today's class, introduction of the electrochemistry and about redox reactions. Redox reactions are involving in both oxidation and reductions. Any reaction involved in oxidation and reductions, that is called redox reaction. The example of redox reaction is the Daniell cell. Daniell cell. So that is a zinc rod is dipped in zinc sulfate solution, copper rod is dipped in copper sulfate solution. The two are connected to the external circuit as well as salt bridge. That is the overall construction of the Daniell cell. So from that we'll get the overall cell EMF. The EMF calculation equations will be there. After that, Nernst equation derivation will be there. So that Nernst equation is applied to the various concepts of like chemical cells and concentration cells. The chemical cells again with transference and without transference, and concentration cells also with transference and without transference, right? So these all concepts will be applied by Nernst equation. Then we'll get the EMF of all those concepts like chemical cells and concentration cells. Okay. So this was the topics covered by today's class. In today's class. So the remaining topic will be continued in tomorrow's class. Okay. Chemical cells with transference will be there. Then concentration cells without transference is there. Then concentration cells with transference and also liquid junction potential LJP will be there, right? Up to here, and if the next summer topics that are covered in the next class. Yes. So tell me, is there any problem in online class? Means, so one of the problem, so I can use mic for the next class. So the voice will be increases. So that I will take care about, right? Right now, so my laptop is not connecting the headset. So that was the problem. So I can rectify that problem. I will enhance the volume. Then is there any other problems? Yes. Yes. Is there any other problems? Notified. Otherwise, I am going to conclude the class. Okay, fine. So you people may join in the next class. That will be at 7:30 onwards, right? So we have tomorrow afternoon session 1 o'clock class will be there. So we'll discuss briefly about this introduction part and continue further topic. Right? Right. Right now I'm going to conclude the meeting. Right? So you have to join in the next further class.